In this video, I want to keep track of potential differences throughout a series circuit and the current throughout a series circuit. So I have an 18 volt potential difference, and I've wired 3 resistors in series across it. Resistors are a little bit like light bulbs. They turn electrical energy into heat, but they don't give off light. They're used in circuits to dissipate energy in very specific ways, and you can get them in lots of different values of resistance, so you can get precisely what you need. So we're going to try to figure out, we have 18 joules per coulomb potential difference across the entire circuit. What's the potential difference across each of these? We've talked about a charge being walking up a mountain, basically, and then each resistor is it moving partway down the mountain. Let's see how much of that 18 gets taken up by each resistor. In other words, what's the voltage drop across each? I think the biggest thing in dealing with circuits is being organized. I like to make a little table. And typically we're interested in the potential difference across each resistor and the current through it. So I list each resistor, I write a row for the total, and then I have a column for potential difference in current. In a series circuit, because resistances just add, the easiest thing to do is calculate total resistance, which in this case is 936 ohms. Then we can pretend that there's a circuit with just one resistor, and that would be it right there. It's very obvious that the current through that one resistor is the current through the battery, so we're going to use Ohm's law to find that. So there we are. V equals IR, I equals V over R. The current through that one resistor would be 0.0192 amps. Notice I've gone over to my table and put it not just for the total, but for all of them. And the reason for that is that any charge that gets pumped up by the battery, for it to return where it started, it has to pass through all 3 resistors. So in a series circuit, all resistors get the same current. At this point, we have the resistance and we have the current for each circuit element. We can calculate the potential difference across each just by multiplying them together using Ohm's law again. So I've done that now for each resistor, and I've gotten the voltage drop across each. And if you add these up, you get the total, which is what we expect because of Kirchhoff's loop rule. We're pumped up 18. We have to lose 18 to get back where we started. If we look at the patterns, we can see we get the biggest voltage drop in the element that has the largest resistance, the smallest in the one that has the smallest. The nice thing about building tables like this is it sort of tells you which piece of the puzzle you have to do. It also easily enables you to check your work because you can look for the pattern. Does everybody have the same current? Do the voltages all add up to the total? So we'll do these for other types of circuits as well, but this is a decent example of a series circuit. I have some other examples as well. If you need to stop and take a look through these, feel free to do that. And I'm going to ask you to try some of your own.